Hello everyone, welcome back to Salvage Geek. Today on the bench we have a beautifully boxed Android car stereo, and apparently the backlight is no longer working. So we are going to troubleshoot it, see what's going on with it. So let's get started. Well, it looks like we have all of the cabling and everything here that we need. Back in the box for now. Remove this harness for now, and this one. Let's see what we're dealing with. Oh, this is nice. Funky Monkey. So this was in a uh, Mazda 5, I think it is. Apparently the backlight's no longer working. So we're gonna start by taking it apart and getting to that circuitry. One on that. Probably going to need to get into this section here, but we'll see if this heavy rear amplifier section can detach from it just to make life a little easier. I'm going in blind. I don't have any schematics or details for this. So this would be a fun one. See what we're dealing with. So assume this is our backlight right here. And then everything else is this is obviously display, and then the other two would be touch screen, and then probably some of these capacitive buttons are this. This is probably the touch screen digitizer. That would make sense. So, before we dig too far, what we can do is play with this. See, that tape's come off. That tape's come off too. So uh, nothing obviously gone with it, but you never know. we're gonna rig this up to power it, and I will put a oscilloscope on that power output for the lighting and see what we're getting. So it'll be black will be ground, yellow will be constant power, and red will be ignition power if it's a standard car stereo arrangement. Set this pretty low right now. Current limiting power supply. Just so we don't, if we have any problems, it's not going to destroy anything. So we've just powered it on. It is drawing 0.56 amps. It may have hit my limiter, so I'm going to turn it up a bit to 1 amp. Yeah, we're getting almost to an amp. I don't see anything on the screen. Tempting to power up on the screen. Get nothing on that connector. But I'm also not sure if anything's... Oh, yeah, okay, I see things at this angle. If I can get you guys to see that too. I can see a fan control symbol there. So things are happening. I see a Google Maps symbol. There we go. Yeah, Google. So what we have here, this should be pulse width modulation signal, but also a constant current circuit telling these lights to come on. Something else I can do here is put in a temporary power signal. Alright, so we have a temporary feed, and what we're going to do, we're going to do 50 milliamp, and we're going to start at 3.5 volts. See if the backlight comes on. So we are on now, and we're going to slowly put the voltage up. We're not getting anything. There we go. There we go. So the backlights are good. We're at 18 volt, or sorry, 18 volts, 120 milliamps. So it would explain why the oscilloscope kind of showed nothing on it. Alright, so let's turn that off. So now we know that the display's good. It's something on the main board. So our next step will be to try and follow the connector here and see where is it going. Um, Without a schematic, we'll have to trace back the traces on the board and just kind of go backwards from there. That's our only real option at the moment. And it's kind of difficult with all this stuff hooked up. So I think what we're going to do is disconnect all these ribbon cables. Let's turn it off, obviously. Power is off now. We're going to disconnect all these other cables, get them out of the way. Okay, so let's do some testing here. We're going to follow what we can see. And what I can see is that this pin here, 1.1 ohms to ground. This one is 200 ohms to ground. This one, with continuity there. Okay. Let's do some testing here. 1.2 ohms to ground on that one. 200 ohms to ground on that one. Let's see what it was showing here. Okay. So this one is negative, but it's not grounded. 1.3 ohms. But I can see this trace, which goes here to this resistor bank. Here we get 1.2 ohms, which makes sense. We got 2.2 parallel. So from there, I'm gonna let it not focus on my hands. 0 ohms through this inductor. 0 ohms. Then we're going to this diode, which I've tested. This diode is good. And from here, it looks like we're going to the center pin on this guy. So this could be a culprit here. I've tested the diode. I know this inductor's good. We're going straight through. The resistors are good. I haven't figured out where this positive pin is going just yet, but I'm willing to bet that it's on this chip somewhere. Wow, allegedly it's going there. So do a proper resistance measurement of that. Okay, so it's going directly to this pin. Our negative is going through here back for this diode. However, if I test the diode, it's doing its job. So I'm going to have to get this under the microscope. That'll be our next step. So here's our little chip. Very dirty in here. Very crusty. I don't like that. So this line goes directly to our positive output. We also have this capacitor here to ground. Which I'm interested in if that has become shorted, because what is this? This is definitely ground. No, we got 200K. So what I want to do next is look up a data sheet on this chip here, and then we can kind of figure out what's going on. So our negative on that chip goes through this little guy here. Into that section. So let's look up the data sheet for this chip, which HYGPB, whatever that is. Let's find it. Okay, so let's do some measurements here. We're gonna power this up. And we're just gonna take a couple voltages. I want to see what we're getting at these pins on this chip, so we can help identify this chip. I'm in diode mode. So we have full 13 volts on pin 6. Nothing there. 0.5 volts on pin 4. Nothing on pin 3. Pin 1, 13 volts. And this one, middle one here, should be ground. Which we can test that here. Yeah. All right, so we've got our oscilloscope hooked up. And when we put it on here, we are getting a pulse width input at 8.9 volts. And I believe it is this chip that is bad. It's getting really hot. So we are getting our input according to this data sheet that I've found. So let me just power this down. So this is a little diagram that I've made. It is a beautiful masterpiece of artwork. Now, the chip, the numbers that are on that IC, I've tried searching for them and it seems that nothing exists. I don't know what it is. But using this crude little diagram and going online and spending about 20 minutes going through multiple different pulse width modulation LED driver ICs, I found a couple of them that have an identical pinout to this. Now, there are lots that don't have the same pinout, so I wanted to make sure I found 3 or 4 that had the same, and that's basically a little trick you can do when you don't know what a chip is. As long as you kind of make a little diagram like this, you can go through data sheets, and most data sheets will have a sample circuit diagram similar to this, normally at one of the bottom pages, just to give an example of how to use it. So when you do something like this, you can go through data sheets, match it up, match the voltages, match the pinouts, and find something similar like I'll show you next. Okay, so what I found here is a similar to what I think is going on. It seems to be wired in a very similar method for our LEDs. And from what I can tell, we are getting our switch power, we're getting our voltage in, everything's good there. We are getting a pulse width modulation signal to the control circuit. We have ground. Everything seems good, except for the chip itself, and the chip is getting very hot to the touch. So I am going to call it and order one of these, and we're going to go from there. And we'll see how it goes. Alright, now that the new chip is in, I've got the power connected here. I'm going to partially assemble this, put the ribbon cables in, and give it a little test before I put it all back together, just to make sure it's actually fixed. Alright, so now I've got everything connected that needs to be connected. So I've got it plugged back into our power supply and powering it, but something's not working. I gotta give it a little jiggle. There it is. My ground connection on there was loose with the crocodile clip. And here you can see the backlight is back in light. So it turned out that it was that particular chip that was causing the issue. And I'm glad to see that everything's working here. And just before I put it away, I just want to play with it a little bit, try out some of the brightness settings and keep it on for a few minutes just so I know that it's not going to burn up and die right away. And we'll do that, and then we'll start putting it back together, and then we'll do one final test with the unit assembled and completed. Alright, so here it is, all back in one piece. We're gonna hook power to it for one last time just to make sure that everything is still working now that we have it assembled. Hopefully nothing came loose, and just make sure to test all the buttons to make sure capacitive buttons on the side, make sure they still work. Touch screen, all of that, and this one can go back to its rightful owner. I really enjoy making these videos and reading the comments and seeing what you guys have to say, so make sure to subscribe, like the video, give it a thumbs up, and leave a comment. Let me know what you think. Let me know if you have a similar stereo and this worked for you. I did notice looking online that a lot of people had this same issue and no one seemed to have a repair for it. And a lot of these things are out of warranty when it happens. So definitely let me know your experiences with this, and if this fix works for you. I'll post the part number in the description of the video. I got it from Digikey. It was quite cheap. And have yourself a good day.
Salvage Geek, we're gonna fix it. Salvage Geek, yeah, yeah.